everyone, and welcome back for another deep dive. So get this. Astronomers have found a black hole that's 36 billion times the mass of our sun.
Wow.
I know, right? 36 billion. And to get into how they found this monster, we've got some pretty cool sources. They mentioned something called an Einstein ring and a galaxy system called the Cosmic Horseshoe.
Yeah, it's pretty amazing stuff.
So to start, what's the connection there?
Well, the Cosmic Horseshoe is where this black hole was found.
Okay.
And it's the system where we see what's called an Einstein ring, which is this really wild visual phenomenon. Imagine this. You're looking at a distant blue galaxy.
Okay.
And right in front of it is a closer red galaxy.
Okay.
The red galaxy's gravity is so strong that it actually bends the light from the blue galaxy around it.
Oh, wow. So instead of seeing the blue galaxy directly, we see its light, like, warped into a ring.
That's exactly it. And in this case, the ring is distorted into a horseshoe shape, which is where the name comes from.
Oh, that makes sense.
It's called gravitational lensing. And it's predicted by Einstein's theory of general relativity.
Okay. So we have this cosmic horseshoe, which is already a pretty cool example of gravitational lensing. But how did that lead to the discovery of the black hole?
Well, that's where things get really interesting.
Okay.
The amount of bending in a gravitational lens depends on the mass of the object that's doing the bending. So in the case of the cosmic horseshoe, astronomers realized that the red galaxy alone couldn't account for the amount of bending that they were seeing in the Einstein ring. There had to be something else there.
Right.
Something much more massive, hidden from our view.
Okay. So that's where the black hole comes in. It's like a cosmic detective story.
It really is.
Yeah.
The black hole's intense gravity is amplifying the lensing effect,
Oh, okay.
making the Einstein ring appear even more distorted than it would if it were just the red galaxy's gravity at play.
So we can't see the black hole directly, but we can kind of infer its presence based on how it's warping the light from the background galaxy. That's wild. But wait, didn't you say that this cosmic horseshoe was discovered back in 2007?
You have a good memory, it was. But the presence of the supermassive black hole wasn't immediately apparent. It took years of further observations and analysis to tease out the subtle gravitational signature of this hidden giant.
It seems like finding a black hole this massive was a real challenge, even with the help of gravitational lensing. What were some of the hurdles that astronomers had to overcome?
One of the biggest challenges was precisely measuring the amount of bending in the Einstein ring,
Right.
because even the slightest error could throw off their calculations.
Yeah, for sure.
It required incredible precision and some very sophisticated modeling techniques to isolate the black hole's gravitational influence from all the other factors at play.
So it wasn't just a matter of pointing a telescope and saying, yep, there's a black hole. It was a lot more detective work involved.
Absolutely.
It really highlights the incredible ingenuity and persistence of these astronomers.
Yeah, it's pretty amazing.
This is already blowing my mind, and we've only just begun.
Right.
Now, our sources also mentioned something about dark matter playing a role in all of this.
Oh, yeah.
What's the connection there?
Well, that's a whole other layer of complexity.
Okay.
Dark matter is this mysterious substance that doesn't interact with light, so it's invisible to us.
Right.
But we know it exists because of its gravitational effects on visible matter. And it turns out that dark matter may have played a crucial role in the formation of these supermassive black holes.
So something we can't even see might be responsible for creating the largest objects in the universe.
That's the idea. And there's this fascinating connection scientists have observed.
Okay.
The more dark matter a galaxy has, the larger its central black hole tends to be.
It's like a cosmic recipe. More dark matter equals a bigger black hole.
Kind of, yeah.
Yeah.
But how exactly dark matter contributes to black hole formation is still a bit of a mystery. Something that researchers are actively trying to unravel. Like we have all the ingredients, but we don't know the exact steps of the recipe yet.
Okay. This deep dive is turning into a cosmic feast.
I like that.
So we've got this massive black hole lurking in the cosmic horseshoe, its presence revealed through gravitational lensing.
Right.
And dark matter might be playing a role in its formation behind the scenes. This is already more twists and turns than a sci-fi thriller.
It's pretty exciting, right?
Yeah, absolutely. Tell me, what are the implications of finding a black hole this massive? Does it change our understanding of the universe?
That's where we're heading next. Because believe me, you're not going to believe what this discovery means for our current theories about black holes and the early universe.
Oh boy. I'm ready.
Okay, good.
Let's get into it. All right, I'm ready to hear how this huge black hole changes what we know about the universe.
Okay, so basically the size of this black hole is like really hard for scientists to wrap their heads around.
Okay.
It challenges our current models of how black holes even form and grow.
Hmm.
We're talking about a black hole that's like pushing the limits of what we thought was possible, especially considering the age of the universe.
So it's not just big, it's like unexpectedly big.
Yeah, exactly.
Yeah.
Like finding a dinosaur fossil in a layer of rock it shouldn't be in.
Hmm.
The universe is throwing us a curveball here.
Hmm.
Our current theories don't really explain how a black hole could get this massive in the time that's passed since the Big Bang.
So are scientists like scrambling to try to come up with new explanations for this?
Oh yeah, absolutely. This discovery has sparked a ton of activity in the scientific community.
Okay.
Researchers are proposing new ideas, refining old models, and even questioning some of the fundamental assumptions.
So what are some of the leading theories that are being thrown around?
Well, one idea is that these ultra-massive black holes may be formed through mergers of many smaller black holes,
Okay.
like a cosmic domino effect where black holes keep merging and growing larger over time.
Okay, so instead of one giant leap, it's more like a bunch of little steps that eventually lead to this huge size.
That's one possibility. Another idea is that focuses on the conditions in the very early universe. Remember we talked about dark matter's possible role in black hole formation?
Right, the mysterious cosmic scaffolding.
Yeah, exactly. So in the early universe, things were much denser and hotter.
Right.
Some scientists believe that those conditions may have allowed black holes to form way faster and get much bigger than they could today.
So they kind of got a head start in the cosmic feeding frenzy.
Exactly.
But even if we figure out how these massive black holes formed, isn't there some sort of theoretical limit to how big a black hole can actually get?
That's a question that has puzzled physicists for decades.
Right.
While there are theoretical limits, we haven't really observed them in practice.
Mm-hmm.
And each time we find a black hole that's bigger than we thought possible, it kind of pushes those theoretical boundaries further out.
So it's like the universe is constantly challenging our assumptions and making us rethink what we know about these black holes.
Exactly, and that's what makes this discovery so exciting.
Right.
It's not just about finding a big black hole, it's about questioning our understanding of the universe and how it works.
Okay, this is like seriously mind-blowing stuff.
Oh, yeah.
But I have to ask, why should we care about a black hole that's billions of light years away? Does this actually have any implications for us here on Earth?
That's a great question. And while this black hole isn't going to, eat Earth or anything,
Okay, good.
its discovery does have some profound implications for our understanding of the universe and our place in it.
Okay, tell me more.
Well, for one thing, studying these extreme objects helps us test our current scientific theories,
Okay.
like Einstein's theory of general relativity. By looking at how gravity behaves around such a massive object, we can see if our theories actually hold up or if we need to revise them.
So black holes are like cosmic laboratories for testing our most fundamental theories.
That's a great way to put it. And the more we learn about black holes, the more we understand about how galaxies form and evolve, including our own Milky Way galaxy. Remember, every large galaxy that you've seen seems to have a supermassive black hole at its center, and they play a really important role in the galaxy's structure and evolution.
So these black holes aren't just like cosmic oddities, they're actually essential parts of the galactic ecosystem.
Exactly. They actively influence the formation of stars, the distribution of gas, and the whole dynamics of their host galaxies.
Okay.
So understanding how black holes work is really important for understanding the larger story of the universe.
It's like a chain reaction. This massive black hole discovery leads us to question our theories, which helps us understand galaxies better.
Yeah.
And ultimately, it sheds light on the origins and evolution of the entire universe itself.
That's the beautiful thing about science. It's all connected. What we learn from these distant objects can really help us understand the universe as a whole, including our own little corner of it.
Right. It's a reminder that even these super far-out discoveries can teach us so much about the cosmos.
Absolutely.
Yeah, it really is amazing to think that by studying something so far away and so different from us, we can learn more about our place in the universe.
It is, yeah. It makes you feel pretty small.
Yeah, it does. It's humbling. Now, before we finish up this deep dive, I have one more question. We talked a lot about gravitational lensing and how it helped astronomers find this huge black hole, but is that the only way that we can find these things?
Oh, that's a great question. And actually, no gravitational lensing is just one way to find them.
Okay.
Another really cool technique is to look at the motion of stars and gas clouds near the center of galaxies.
Oh, interesting. So instead of looking for the distorted light, we're looking for something else that's kind of giving away the black hole's presence.
Right, think of it like watching a swarm of bees around a beehive, right?
Okay.
The way that they're moving can tell you a lot about the hive itself, even if you can't see it directly.
Right. Right.
It's the same with black holes. If we see stars and gas clouds swirling around a galactic center really fast, it probably means that they're being pulled by the immense gravity of a supermassive black hole.
So it's like watching a cosmic ballet with the stars and gas clouds as the dancers and the black hole as like the choreographer.
That's a great way to put it. And by measuring the speed and the path of these dancers, astronomers can actually calculate the mass of the black hole that's orchestrating their movements.
Wow. It's like we're using the motion of the stars to weigh something that we can't even see.
That's right.
It's pretty incredible. Are there any other ways that we can find black holes?
There is. And it's a completely new field of astronomy. It's called gravitational wave astronomy.
Oh yeah, gravitational waves. I've heard that term, but I don't really know much about it.
So basically, when supermassive objects like black holes collide with each other,
Okay.
they create these ripples in space-time, kind of like waves spreading out from a stone thrown into a pond.
Right.
These ripples are called gravitational waves.
Okay.
And just like we can use sound waves to learn about things that we can't see, we can use gravitational waves to detect and study these black hole collisions that we wouldn't be able to see otherwise.
Wow. So we're basically listening to the sounds of black holes colliding.
Pretty much, yeah. It's led to some huge discoveries.
Mm.
Like back in 2015, scientists made the first ever detection of gravitational waves.
Wow.
Yeah, it was a huge deal. It proved Einstein's theory of relativity was right, and it opened up this whole new way of looking at the universe.
So we're not just limited to seeing how black holes affect light. We can also detect them through their gravity and even like listen to them collide.
Exactly.
It's wild. It seems like our senses are expanding as we explore the universe more and more.
I know, it's amazing, isn't it?
Well, this whole deep dive has been incredible. We've gone from a mind-bogglingly massive black hole to talking about how gravity works, and we've even touched on dark matter.
It's been fun.
It has. If we had to pick just one thing to take away from all this, what would it be?
I think the most important thing to remember is that the universe is full of surprises,
Right.
and our understanding of it is always changing.
Hmm.
This black hole discovery is just one example of how much we still don't know about the universe and all the forces that shape it.
And I think even more importantly, it's a reminder that we should always stay curious, always ask questions, and never stop exploring the universe.
Well said. That's what pushes humanity forward, that curiosity and that desire to figure things out.
Nicely put. On that note, we're going to wrap up this deep dive into this huge black hole discovery.
Thanks for having me.
Thanks for joining. To everyone listening, until next time, keep looking up and stay curious.